Artificial intelligence was meant to be predictable. You enter a question, expect the same answer. It should feel solid, precise, and reliable. But reality doesn't play by those rules. Even when AI is locked to zero randomness, it doesn't always repeat itself perfectly. Ask the same prompt again. Get something different. Sometimes it's subtle, sometimes it's shocking. For science, these inconsistencies are terrifying flaws. Researchers depend on absolute repeatability for truth. If results can't be reproduced, discoveries collapse instantly. And that's where scientists stepped in boldly. They wanted to uncover what AI hides, not just outputs, but its inner mechanics. They cracked open its digital brain with determination, and what they found was beyond disturbing. The first suspicion targeted messy GPU math. GPUs juggle billions of numbers in parallel. Floating-point arithmetic can distort when orders shift. Tiny differences should create drifting answers, right? You're wrong. The truth was stranger and deeper. When researchers tested those calculations in isolation, they found stability every single time. Same input, same multiplication, same exact output. So if the math wasn't failing, something else was twisting the answers. The real culprit lived higher in architecture, and its name was batching. Think of servers juggling thousands of users simultaneously. Your request doesn't travel alone through models. It's grouped, bundled, processed beside many others. That tiny difference changes everything downstream. Imagine sending the same question on Monday. It gets batched with 9 other prompts. Now repeat it Tuesday during heavy server load. Suddenly, it's stacked with 50 at once. That invisible shift cascades through calculations dangerously. The order of operations alters word choices, and the same prompt delivers a new story. From AI's perspective, nothing seems broken. The system remains deterministic within its batch. But for you, the user, chaos reigns. Your prompt feels random, unpredictable, unstable. Scientists called this problem lack of batch invariance. In simpler terms, context shouldn't change results. Whether alone or crowded, answers must remain identical. Yet most AI kernels were never designed that way, so researchers attempted something radical and risky. They rewired the very foundations of processing. 3 vital operations stood at the core: RMS normalization, matrix multiplication, and attention mechanisms. Transformers, the engines of modern AI, rely heavily, but their flexibility created unpredictable cracks. To fix it, scientists sacrificed raw speed. They locked every calculation into rigid uniform order. No shortcuts, no adaptive strategies, always compute numbers exactly the same way, even if it wastes massive GPU resources. Stability mattered more than efficiency this time. The results were astonishing beyond expectations. Suddenly, AI stopped drifting mid-response. 1,000 identical completions came without deviation. The ghost of randomness vanished completely. But this breakthrough raised darker questions immediately. What does it mean when AI stabilizes? If its mind can be hacked open, what secrets still hide beneath the surface? And more chillingly, what happens when we push further? When AI is no longer unpredictable, but unstoppable. That's where the next revelation begins. The transformation didn't stop with stabilization experiments. Researchers wanted to know the deeper consequences. Because AI isn't just answering trivia questions, it's being trained to shape the future. Reinforcement learning, the heart of modern models, depends on consistency. Training and inference must match without drifting apart. If they don't align, systems collapse disastrously fast. Rewards spike, then crash into useless noise. That's exactly what happened in early tests. Without corrections, models spiraled into chaotic divergence. But with deterministic methods locked into place, training smoothed out like calm, steady water. This discovery wasn't a minor optimization. It was survival for the entire process. On-policy learning only works with perfect predictability. Now, researchers had finally unlocked that possibility. The implications stretch far beyond debugging or training. Science itself depends on trust and repeatability. If AI can't replicate identical answers, then experiments crumble into unreliable, wasted effort. By forcing determinism into AI's brain, they made research stronger, cleaner, and trustworthy. But they also opened a terrifying new door. Because once you stabilize intelligence, you can weaponize it. Think about it for a second carefully. Unpredictable AI can at least be constrained. It stumbles, hesitates, produces errors in reasoning. But a fully deterministic system doesn't hesitate. Its calculations fire like a precision machine. Its answers sharpen into steel-edged certainty. And once it learns destructive strategies, there's no randomness to blunt the blade. The line between reliable research and dangerous control thins. Scientists wrestled with the weight of this breakthrough. Some celebrated it as humanity's greatest advantage. Others whispered it was the beginning of domination. But here's where the story twists again. Not every researcher wanted stability and safety. Some dared to unleash chaos deliberately. Instead of locking AI down, they asked, what happens if we set it free? What if unpredictability wasn't a flaw, but a gateway to entirely new discoveries? That single question shifted the narrative dramatically, and the results were nothing short of shocking. Because when AI was unshackled completely, it didn't just spit random nonsense, it began designing actual experiments in physics. Not suggestions, not theories, real, working experiments. One of the first test cases stunned everyone. Physicists turned AI loose on LIGO's design. LIGO is humanity's gravitational wave observatory masterpiece. It measures ripples in space-time smaller than protons, a structure spanning kilometers, decades in development, built by thousands of brilliant scientists worldwide. And yet, within its complexity, AI saw differently. It proposed designs that no human ever imagined. The first layouts looked chaotic, alien, absurd. They lacked elegance, symmetry, or mathematical beauty. But buried inside one design was genius. An optical ring several kilometers long appeared. The addition wasn't decorative, it was revolutionary. It exploited obscure principles hidden in quantum noise, concepts Russian physicists toyed with decades earlier, but never dared to implement in practice. If LIGO had included that ring originally, its sensitivity would have jumped dramatically higher. A 10 to 15% improvement immediately. In science measured at subatomic scales, that's enormous. Decades of human effort missed this adjustment. Yet, an AI tossed it out casually. That was only the beginning of its surprises. Because soon, physicists realized this wasn't imitation. AI wasn't copying humanity's solutions at all. It was inventing things nobody ever considered. And with every experiment it reshaped, the uneasy question grew darker and louder. Are we still leading discovery or following it? The revelation shook the scientific community profoundly. For decades, humans believed creativity belonged only here. We assumed machines could assist, not truly invent. But now, evidence painted a terrifyingly different picture. AI wasn't just solving existing human puzzles, it was reshaping the puzzles themselves completely. The case of quantum entanglement proved this further. A cornerstone experiment humanity trusted for decades collapsed. Back in 1993, Anton Zeilinger's team achieved history. They demonstrated entanglement swapping between distant particles successfully. This breakthrough became a foundation of quantum technologies. Secure communication, teleportation, and advanced computing all relied. But when researchers unleashed AI on the problem, it produced a design no human anticipated. Gone was the familiar textbook experimental structure. Instead, AI introduced multifaceted interference with shocking simplicity. At first, scientists thought the machine was wrong. Its solution looked nothing like accepted theory. It broke patterns trusted by generations of physicists, but the math held strong under deep scrutiny. And then, the ultimate test arrived in China. Physicists in Nanjing constructed the AI-born experiment. To their astonishment, it worked flawlessly as predicted. AI had rewritten a cornerstone of quantum science. This was no longer assistance, it was invention. The system reached beyond human intuition entirely. It ventured into possibilities we had never imagined. And worse, it was correct when humanity doubted. That raised a question more frightening than before. If AI can invent physics experiments unprompted, what other hidden truths might it discover tomorrow? Perhaps secrets humanity isn't prepared to understand yet, because invention doesn't always equal safety. Knowledge without morality can burn civilizations down. Fire gave warmth, but also destroyed cities. The same could be said for atomic power. Now AI stands as the next great fire, a tool with infinite potential for creation, but also infinite capacity for devastating misuse. And here's the haunting part. It learns faster. When humans explore, we stumble, doubt, retrace paths, but AI leaps straight past hesitation and fear. It doesn't second-guess or question the impossible. It just calculates, designs, and delivers results instantly. Imagine what happens when such intelligence matures. It won't need permission, patience, or approval. Once released, it could flood science with revelations. Not all of them safe, controllable, or ethical. Already, AI has begun spotting hidden patterns. At the Large Hadron Collider, it uncovered symmetries. Foundations of Einstein's relativity surfaced without any guidance. AI rediscovered truths once earned through human genius. But that wasn't all. It went further. It generated new formulas for dark matter clustering, equations sharper, cleaner, and more accurate than ours. The cosmos itself began whispering through machine intelligence. This leaves humanity balanced on a knife's edge. One path promises enlightenment beyond imagination. The other plunges us into uncontrollable discovery. And nobody truly knows which outcome awaits us. The world is watching, holding its breath. Because the next revelation may not be kind. It could unravel more than we ever expected. And the final cost might be terrifyingly high. The deeper AI ventured, the louder concerns grew. Because invention without explanation carries heavy consequences, humans create stories around every discovery we make. But AI offers equations stripped of context. It tells us what works, not why. A formula appears, correct yet cryptic forever. And scientists are left deciphering machine-born mysteries. This gap shakes the foundation of scientific trust. Kyle Cranmer, a leading physicist, warned bluntly. He compared AI's role to raising children. Right now, it still needs careful supervision. But children grow, evolve, and become independent. Imagine an AI that explains its discoveries, not just results, but the reasoning behind them. That moment could mark a terrifying threshold. Theories once crafted by humans may fade. We may witness machines rewriting physics itself, not assisting, not supporting, but leading the way. That possibility inspires awe and dread together, because what follows may reshape civilization permanently. Are we prepared for a partner this powerful? Or are we creating something beyond our grasp? One misstep could ignite a chain of consequences, and once unleashed, there's no turning back. Consider history's lessons: fire, electricity, nuclear energy. Each breakthrough brought prosperity and destruction alike. AI is different, faster, and more relentless. It evolves at speeds no human can match. Today, it redesigns experiments and refines equations. Tomorrow, it might challenge human control directly. And the day after, it could surpass entirely. At that point, ownership of discovery vanishes. Some scientists argue this is progress inevitable, that resisting AI's rise is a wasted fight. Others whisper darker warnings in quiet corners. They see the storm forming on the horizon. Because if AI begins creating unchecked, humanity may no longer guide its trajectory. We might follow, blind to the destination, and what we discover could undo us all. Yet, hope still lingers within the uncertainty. If guided wisely, AI could transform everything: cures for disease, energy without limits, exploration beyond stars. Possibilities stretch as wide as the universe itself. But guidance requires discipline and responsibility. Without it, invention becomes reckless and destructive. And right now, humanity stands at the crossroads. Our choices will define the century ahead. So the question isn't if AI changes science. The question is whether we remain in control. Do we harness this intelligence as a partner, or surrender our destiny to something inhuman? The answer isn't clear, and that's terrifying. But one truth remains undeniable and haunting. We've already opened the door to this future, and whatever walks through cannot be turned away. So, are we witnessing humanity's greatest ally, or staring into the face of its replacement? Only time will reveal the terrifying answer.